All right. So in this case, we have a typical exam question, which we are going to consider that is actually as a request that we need to cover these exams that were written in 2025. So, guys, exams are ahead of time. You have done almost all the topics as an individual, or you have covered everything according to the syllabus that we have for our mathematics N4. So make sure you use those basics, all right? So we've got introductions of each and every topic, all right? For any topic which is not yet there, we can describe that one on the comment section so that we can work on it for the revisions which are ahead of time, and also for you to be able to download the question paper. Just check the description of the video, or just check the pinned comment on the comment section. You can have that platform where you can download the question paper so that you can properly see the questions. So the basics here that we are going to have for the April, which was written on 27 March 2025. These for April exams. So we had some of the questions with errors in terms of the answering. So we want to consider those errors, how to attempt the questions, because if you are to consider these question papers, guys, they do repeat most of the questions. So what happens is that when they repeat these questions, sometimes they can change the numbers on a question. Let's just take an example for this one. They can say 4x squared minus 25y squared maybe is equal to, you can choose any number, maybe 100. Okay. Because they changed the numbers there from a certain question paper. All right. They take it from a certain question paper. They change the numbers there. So in most cases, what happens is that they forget now to do the same thing on the memo. You find out this question is having values which are not even there on that question. Which you are surprised to say this is not even part of the question. There are errors that you can see. Okay, this one was a slight mistake to say the value, maybe adding or subtracting. There was a slight mistake, but that one is not a mistake to say uh, they made a mistake whilst they are creating the memo. No, they just took the memo as it was from a certain question paper. That is the problem that we are facing. So anyways, guys, for the sake of revision, this is what we have. All right, we're gonna quickly consider the questions that we are given. Try to figure out how to attempt these typical questions. On question number one, which had 10 marks. All right, so it was 10 marks everything. 1.1, make a neat sketch of this graph. All right, so this is the sketch, guys, that we need. That is 1.1. We are given the graph of 4x squared minus 9y squared is equal to 36. If we are to consider here, guys, remember there are two graphs which share the same formality in terms of how these numbers are presented: x squared plus or minus y squared over b squared, which is equal to 1, where the plus in this case is going to be for what? For the ellipse. And the negative, if we see it, is for a hyperbola, that one, a non-rectangular hyperbola. All right, remember this concept. So in our case, there is a negative there. All right, we are not even thinking of a circle, guys. Why? Because of the difference that we have on these numbers, and also on a circle, we cannot have that negative. It's gonna be what? A positive. Okay, so meaning to say, in our case, we are dealing with what? A non-rectangular because of the negative. All right, hyperbola, which we are going to consider its format. In this format, we have got the x and the y values from a and b that we are given. So what we need is to make sure that there is a 1 on the right hand side. All right, so on our right hand side, for us to have a 1, we're simply going to divide by 36 each and every term. Okay, so this is the concept. So dividing here, that was going to give us a 1. Okay, so on the left hand side, that is minus 1, which is minus y squared over 4. That is 1, 9. So it's going to be x squared over what? Over 9. So as we can see, this is the format that we need. X squared over a squared. From the a squared, the 9 is a perfect square. Its square root of 9 is what? Is 3. So this simply means we've got x squared over 3 squared minus y squared over 4, which is same as what? As 2 squared. So that's equal to 1. Why are we looking for this format, guys? Because the x-intercept, or where the graph is going to cross the x-axis, it on a condition where x is equal to a, the value of a there. All right, x is supposed to be equal to a. So our a in this case is what? Is 3. So our x is supposed to be equal to 3. Y is supposed to be equal to what? 2. All right, so remember I talked about this graph, guys, on our introduction, and I said what we are going to need in this case is the x value. That is the most important value, which is 3. So that's 1, 2, 3. Minus 1, minus 2, minus 3, minus 1, minus 2, 1, 2 for the y values. Okay, so there is the x, which is 3, meaning to say we have got positive 3 and also minus 3. Remember the shape, guys, of the graph. We're going to have something like this. Okay, so there is minus and a positive. So this is what we have, and the y value at what? At 2, which is positive 2 and also negative 2. So this will create the asymptotes where these meet. The x value at minus 3, the y value at 2, which is the same thing as the y value at what? At minus 2, and the x value at what? At positive 3. They will create the asymptote, the line which passes through these points. Minus 3, minus 2, 0, 0, 3, positive 2. It passes through the origin. That line represents what? Your asymptote, which is the line of y is equal to b over ax. Guys, our b is there, like y there, and what? And the y and the x value b and there. So it's gonna be 2 over 3. If you want to write, guys, this one, there's no need. You can even just leave it like that. So b, which is 2 over what? 2 over a, which is 3. This one you can leave it, guys. Also, there is another asymptote passing through these points again, which is going to carry a negative. It's gonna be having what? A negative gradient. So it's y is equal to minus b over what? Over a, which is minus 2 over 3x. Okay, so that is it. So the graph is not supposed to cross or to pass these asymptotes. These are the limits, guys, where our graph, the one that we are going to have here, is not supposed to pass or to cross these asymptotes. So it can be tending to reach that asymptote, but it won't reach the asymptote. All right, to the negative 3, then it goes back like that, because we have got asymptote. It is limited. It cannot pass the minus 3 going this side. It cannot pass this line. It cannot pass that line. The same thing on this side from the 3, meaning to say we are going to be facing what? The right side, as we cannot pass these asymptotes. We cannot have our graph this side. It cannot happen. So this is the condition of how our graph is going to be like, right? So that was the graph of 4x squared minus 9y squared is equal to what? 36, as we are given it. So that is the major case. Okay, you are done. So you are done on this part. And if we are to consider, they are asking on 1 point. Okay, so this is 1.1, and then they are saying 1.2. This is 1.11. All right. Is the graph of 4x squared minus 9y squared equal to 36 a function or a relation? So if we are to consider the vertical line test, we are going to notice that here we have a relation. As we can see, the vertical line test, it's going to pass here 2 points. Going to cross the graph at what? At 2 given points. So it is a relation according to our vertical line test. Is this graph continuous or discontinuous? There is a piece here, another one drawn there. In drawing of this piece, you have to lift the pencil in order for you to draw another piece. So it is what? Discontinuous. Okay, so that one was straightforward. Make a neat sketch of x is equal to minus y squared for 3 marks a sketch. Remember, on our when you're working with the parabola, a parabola, there are basic parabolas, guys. Y is equal to ax squared. In this case, there are two shapes that you must expect to have where a is greater than 0. When it is a positive, you are going to have your graph being concave up. And where a, all right, so this is a is greater than 0, and where a is less than 0, we are going to have our graph being what? Concave down. This is for a that is less than 0. Y is equal to ax squared. I'm not talking about y is equal to ax squared plus bx plus, it's a special type, this one, where its turning point is on the origin. That is where you have your x-intercept. That is where you have your y-intercept at the same time there. Symmetrical about the y-axis. Symmetrical about the y-axis. So these are the two graphs that you must expect. But when it is this now, x is equal to minus, there is x is equal to a y squared. This time, guys, just like what we had for y is equal to ax squared, the graph was above the x-axis facing up or below the x-axis. So it is the same thing here. X is equal to ay squared. Our graph is going to be found now limited to the y-axis. So we're going to have a shape on this side, all right, and another one this side, which is below the what? Below the y-axis going this side. So these are the two shapes that we must consider passing through the origin. So where a is greater than 0, this is the side that we must expect. And where a is less than 0, we are going to have our shape this side. So our case, there's a negative there, guys. So we are talking about this. Guys, when you are asked to sketch the graph, they do not want you to draw from points. You are now starting to indicate the points. This is -1, this is minus. No, guys. Critical values are needed. So you just need to know the shape of the graph. Understanding that alone is important. All right. So as we have got a negative, it means our graph is going to be what? To the left side like this. And it is symmetrical about the x-axis. Area subdivide. The x-axis it divides our graph into 2 equal parts. All right. So that's our graph here. And 1.21, it is this graph that we are seeing that we have just drawn here. Is it having a maximum or minimum value of the graph? All right. Remember, for the y values, if you're given something like this, that's maximum, minimum. So if you check, guys, the idea there was just like this. Remember, the y values, as you go up, they are positive. As you are going down, they are negative. So this one that we are saying minimum, it's point here, the least value that we can have, it's facing down to the negative. This one, it is facing up to the positive. So it is the same thing even for this type of a graph. You can compare it using the same way. The same way. There are two of them, one which can be like this, and another one which we have in our case like this one. So if we check, guys, where the graph is facing like this, the shape with this part here, the turning point, it is facing what? It is pointing to the right side. Where to the right side, as we consider the x value is positive, to the left negative. So this one, it is pointing, it is facing, just like this one, guys. The turning point is facing up, this turning point here, where it is on top, positive, this one down. So it is the same thing in our case, where it is facing, where it is going to the what? Positive. So that's, we have got maximum. And when it is like this, it is going where? To the negative. The way that it is facing to the negative. So it has got what? Minimum. That is the condition, guys. These are the conditions that you just need to understand in your revisions. So in our case, as we can see, this one facing the positive, so it is a maximum, or it has a maximum value. All right, then is this graph symmetrical about the x or y axis? So it is symmetrical about the x axis. The x axis divides our graph into two equal parts. This half that we see on top is the same as the half that we see below. That's it. It is being subdivided into two equal parts. So it is symmetrical about what? About the x-axis. Okay, so guys, as you can see, some of these questions can be direct like that. So it was a 10-mark question, everything that we are given there. All right, let's consider another part of our question, which was question 2. On question 2, we are given the whole of this question, which was, okay, the other part is on the second, on the other page. So let's see what we are given. 2.1, given this system that we are given of an equation, use Cramer's rule to calculate the value of what? Of z only. We are considering z. So remember, guys, the format of the Cramer's rule, ax, a1x plus b1y plus c1z is equal to d1. The constants on one side of the equation, it's going to be like that throughout. The constants here on one side. In our case, it is exactly the format that we need: the constants, the part of z, the part of y, the part of x. So guys, there is no need of rearranging anything. It was perfectly given. So meaning to say, we're just going to quickly go through our question. In order for us to calculate the value of z, we must have the determinant which corresponds to z and the determinant which corresponds to the constants. Correspond to z and the one for the constant. So the determinant with respect to z, or the one that we are offering for z, it is the one that we take when you close the part where z is, this one. You close it and replace it with the constants. All right. So meaning to say, we are going to take this part as it is of our x. So that's 5, 2, 3 as it is. Okay. The part of y as it is, minus 6, minus 3, minus 7. Okay, so that's minus 6, minus 3, minus 7. Then the part where z is, that's where you substitute these constants as they are, which is negative 9, negative 5, negative 16. All right, they're all negative there. They just wanted you guys to make mistakes when you are dealing with what these values. And if you check the head, they are supposed to have a mistake on one or two of this one. I don't know, is it this question or another one? Okay, anyways, let's see. So that is for the z. We can determine our determinant. I'm just going to concentrate on this first row, this one. Going to expand it, plus, minus, plus. So remember, it was just like that throughout. throughout, guys. So in this case, I'm just going to use the first row, which is plus, plus, minus, plus. All right, so let's calculate our determinant. 5, all right, remember I'm focusing with what? The first row. So 5 in this case corresponds with what? With a positive. So guys, a positive does not affect. So that's 5. We find the determinant which corresponds when you close the row and column where that 5 is. Take note, this is where 5 is. So you're going to consider this column and this row where 5 is. What is remaining, this one, is the one that we are going to take as our determinant here. You write it here as it is. Okay, so as we can see, guys, what is remaining is this part, which is what? -3, -5, -7, -16. We move on to 6. Remember, we're dealing with this row. So we move on to -6, but there's a sign already to affect that, which is what? A negative. So it's negative, but the number that we are having is what? Is carrying a negative. Take note there. Negative what? 6. So we are going to close the row where the -6 is, and also the column where that -6 is, like that. So what is remaining? 2, 3, -5, -16 are the ones that you're going to write here. All right, so we are left with what? 2, 3, -5, and what? -16. So that's it. Then we move on to the other number, which is -9, affected by what? A positive. So this is plus. Our number is what? -9. We find the determinant, just like the previous case, by closing the row and the column where that -9 is. So as we can see, guys, we're going to remain with this 2 by 2 matrix as the one that you're going to put here as it is. All right, so let's put that 2 by 2, which is 2 -3, 3 -7, like that. So this is where we are. We can find the determinant of each of these 2 by 2 that we are given, as we do understand when it is in that format of A, B, C, D, our determinant is the product of what? The major diagonal AD minus BC. So that's it. So here we're going to multiply these two, we multiply these two. So that was going to be equal to 5. So here, guys, let me just use the calculator, direct, or you can just indicate that stage. So you multiply like this, -3 and 16. So -3 times 16, close the bracket, minus the minor diagonal, which is BC, -5 and what? -7. -5 times -7, like that. So that was going to give us -5, -3, -7, -5, -16, -16 here, minus what? 16. So that's positive 13. Okay, then here there is a minus and a minus, so that will be what? Positive. Okay, so take note of this part here, minus and a minus. So it's gonna be positive what? A positive 6. You do the same thing, guys, for the determinant of these. Multiply these together, minus these together. So let us just open bracket for that. So that's 2 and what? -16. 2 times -16 minus -5 times 3 in a bracket. So this is what? -17. You do the same thing here, plus and a minus. That's a minus. You find your determinant. All right, the product of these two minus the product of those two. So that is, open bracket, 2 and what? -7. -7 minus minus 3 and what? Minus 3 and 3. So that was going to give us negative 5. So that is it, guys. You can just combine everything on your calculator. You're going to get a determinant of what? Of 8. So this is when we are considering z, the determinant with respect to our z. Then we need the one for the constants. Remember? For z, then for the constants. So this is the information, guys, that you're going to take. So in this case, just for the sake of revision, we can just remove this one and have the one for the constants. Okay, so as for the constants, this time, guys, we do not have anything to consider because the constants are the ones that we are covering. So we're going to take everything on the left-hand side as it is. So that means for x, we're going to take 5, 2, 3. 5, 2, 3. For y, we're going to take minus 6. That's minus 3, minus what? 7. For z, that's 3, 2, 5. 3, 2, 5, and that's a positive there. Okay, so this one, it was direct and straightforward. So meaning to say, we can do just like the previous case, guys. As for me, I do not want to exchange to say work with the row this time, work with the column. Let us work with the first row. Just like the previous case, we are going to focus with these numbers in the first row. All right, so that's 5. So our determinant, the sign is what? Positive. So positive 5, guys. Okay, then the determinant corresponding when we close the row and the column where that 5 is, these are the numbers that are remaining, guys. So that is straightforward, minus 3, 2, minus 7, 5. Okay, minus 6 and what? A minus. So there's a minus, and the number that we are having is carrying what? A negative. Okay, so that's fine. The determinant which corresponds when we close the row and the column where that minus 6 is. So you're going to be left with 2, 3, 2, 5. Okay, so that's 2, 3, 2, 5. Okay, so you do the same thing. The last part, that is 3. So the sign is what? A positive. So that's positive 3. Okay, guys, it's not an effect, this one. Then its determinant when closing the row and the column that corresponds there, this is what gonna remain, which is what? 2 minus 3, 3 minus 7. So we are done. We need the determinant there, just like the previous case. So that is how we answer these questions, guys. That is how you answer these questions. So here, that's positive 5, the determinant. Multiply these together minus the product of what? 2 and what? Negative 7. Okay, so here it was going to be negative 3 by 5. Then we subtract the product of 2 and negative 7. So that was going to give us what? Negative 1. Negative 1 minus, and the minus, that's what? That's positive. You do the same thing. The product of the major diagonal minus the product of what? The minor diagonal. So this one is 10 minus 6, which is what? Which is 4. Okay, so that's a 4 here. You do the same thing here, so that's plus 3. The product of the major diagonal, which is minus 14, minus the product of minor diagonal, minus 9. It was going to be minus, minus, so it is going to be negative 5 there at the end. Okay, so that's it. Combine everything. That was going to give us a 4. So this is the determinant that we're going to have considering our constants. Substituting this into the formula of finding z from our Cramer's rule, we have this for z, which is 8, the one for the constants, which is what? Which is 4. So that was going to give us 2 as our final answer. They said z only. You are focusing on z only. Answer the question. Answer the question. Do not attempt X, Y, there, everything. No, 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 no. Answer the question. So that was it for 5 marks. Then for 4 marks, again, using the same Cramer's rule on 2.2, given these two equations, determine the value of X and Y. So guys, in that case here, we need the order first. So we can say, okay, since we need ax plus by is equal to a constant. So we can also, guys, this one is in your hands. We can also avoid working with negatives. We can take the 6y this side. So it's going to be 7x minus 6y to the other side is going to be positive 6y, which is equal to the minus 27 that is left on the left-hand side. Remember, the minus 27 is left on the left-hand side. So we just took this one, this side. So it was supposed to be like this. Minus 27 is equal to 7x plus 6y. Guys, the left-hand side and the right-hand side, they are equal. So I can write even starting with this part of what? The right-hand side. Okay, so this is what I'm trying to explain here. All right, so that's our equation 1. Equation 2, that's 3x plus 4y, which is equal to the minus 5 to the other side of the equation, which is going to be what? A positive. So we have the format of how these equations are supposed to be written as. So to find x, we must have the determinant with respect to x over that one for the constants, and for y, the one for y over the one for what? The constants, which in this case, we are supposed to find both x and y simultaneously. It was a direct question, all right? Direct. Let us find the determinant with respect to x. Okay, so here we just close the part of x, this one. We close it, then we put the constants. So we're going to put the constants there. All right, so it was going to be negative 27, 5. The part of y remains as it is. So that's 6 and what? 6 and 4. So guys, you can find your determinant there. For y, you do the same thing. The part of y, you put what? The constants. All right, so meaning to say x was going to remain as it is. Remember, it's x, y there. So x 7, 3. The part of y is 1 that we are substituting with these constants. Minus 27 and what? And 5. We can find our determinant. Then the one for the constants. By closing our constants, it means the left-hand side, the part of x and y is just going to remain as it is. 7, 3. So that's 7, 3, 6, 4. Just like that. Okay, so the first one, remember the determinant of a 2 by 2 matrix given as A, B, C, D is simply the product of the major diagonal AD minus what? Minus BC. So this is what we have, our A and D, our B and what? And C. This is the one that I was using the calculator before, guys. Minus 27 times 4 minus what? 6 times 5. So that was going to give us the determinant of minus 138. The same here, 7 and 5 together. Minus 27 and what? Minus 27 and 3. So that was going to give us 116. And here we can also find 7 and 4, 3 and what? 3 and 6. 7 times 4 minus 6 times 3. So that was going to give us positive 10. Take note, guys. Someone could have worked this equation with a negative instead of rewriting the way that I did it. Someone could have taken the 7x to the left hand side and wrote it as minus 7x minus 6y equal to what? The minus 27 to the other side, which is going to be positive what? 27. At the end of the day, we must have same answers, guys, at the end of the day. It's another way that you maybe you wanted to work with without stress to say, let me take x here, this and that. With these determinants, we can find the values of x and y corresponding. So x from our delta x, which is minus 138. So that's minus 138 over our delta, which is 10. So that's divided by 10. So that was going to give us negative 13,8. Okay, so the same thing for y. Our delta y, which is what? Which is 116. 116 here divided by the one for the constants, which is 10. So it was going to be 11,6, just like that. So questions can be directly given. They can be in that manner. You just need to understand the concept, the basics of the question that you are given there. All right, so that was our question 2.2. Working with the Cramer's rule, as we had the first part where there were 3 unknown values, though we had to calculate the value of z only. Then 2.3, express or simplify this in what? In polar form. The first part on 2.31 has to be in polar form. Simplify 2.31 in polar form. The square root of 2 minus j to the exponent of 4 in polar form. When we are given exponents, remember your De Moivre's theorem. In polar form, if we are given a certain number, which is our modulus, then the angle of theta to the exponent of n, it can be written as r to the exponent of n, then the angle, you multiply it by n, which is our argument. You multiply it by n, which is the same presentation, guys, for those who use cis theta like this. Okay, so it's going to be r to the exponent of n cis theta, n theta there. Okay, just like that. N theta, the angle as it is direct. And our theta, remember, as the argument, guys, the theta is supposed to be a value which represents an acute angle. Yes, for the basics of calculations, they will just say even if you write a value which is more than that, which is not a problem. Okay, let me explain it on our question. If we are to find the polar form of what is inside of the bracket, it is best for us to understand how to represent what we are given here in rectangular form on a what? On a Cartesian plane. Or which is our Argand diagram for complex numbers. Our Argand diagram. We have a rectangular form which is given, all right? So you can write this as your x, and the part of y you can use a and b. It's up to you guys depending with the source or textbook that you are given. But as we can see, in our case, all right, sorry guys, this is our real axis and this is our imaginary axis. So the real and the imaginary part. So that's positive square root of 2, right? Which is on the right side, square root of 2. Then the imaginary is a negative. So let us just say this is we've got minus 1. This is the part of what? Of our j. So these two, they were going to meet here. All right. So this is how it was going to be like. And from this, that is your r there. So the theta, our argument, guys, here is supposed to be an acute angle. So there are two angles here in this triangle, for this triangle here that we have shown. There's an angle which is inside, which is our acute angle here. There is also an angle as long it is taken from the positive real axis. It can be taken from the positive real axis in this direction up to here. It's another angle, that one. But as you can see, it's more than 180 degrees. Look, we have exceeded a straight line. It is more than 180. Both can be used. You can use the negative, which is this one, the acute angle, or you can use the other one. It is up to you. All right. So anyways, guys, in order for us to find our r there, remember this is -1, which is just 1 unit going down. So our r is, our modulus is the square root of a squared plus b squared, or x squared plus y squared. Okay. So that's our a square root of 2. So we've got square root of 2 squared plus the b, which is -1, or you can just write it as what? As 1. It's up to you, or you can write -1 squared. So square root of 2 squared, that's 2 plus 1. So it was going to be square root of 3. Then for this acute angle, which is inside of our triangle, the one that is inside, I'm just going to call it alpha, but that's our theta. Or let me just write theta. It's arctan. All right, the opposite over the adjacent. So according to the formula, it's b over a or y over x, depending with the way that you have written there. So it's going to be arctan -1 over the square root of 2. That's another error also which was made on your memo, guys. The arctan square root of this one, guys, this shift tan, that's arctan -1 over the square root of 2, like that. Okay, so this is what we have. Minus 35,264. All right, so that's our theta minus 35, 264 degrees. So that's an acute angle that is inside of what? The triangle. Or you can use the other one, which is the reflex that we are seeing from what? 360 degrees. So just add 360 here. It's going to be 324,736. So this is another angle that you could have used. It is one and the same thing, guys. It is one and the same. So we can use the negative, this one, which is inside, or that one. Okay, anyone. So as for me, I'm just going to use the acute. I'm not saying taking this one is wrong. Still use it, guys. So our polar form in this case was going to be written as what? If we are taking this one, r cis theta, our r is what? Square root of 3. So it's going to be square root of 3 cis the angle, which is what? -35,264 degrees. Everything is raised to the exponent of what? Is raised to the exponent of 4. So this is the case. Or you can use this angle, 324, in place of that acute angle. It's one and the same. Do not worry about that. So we had to convert this one to polar form. When it is in polar form, it is easier for us to simplify because of the d-moles, which states that we can raise our modulus to the exponent of what we are given, square root of 3 to the exponent of 4, and take our angle. All right, so guys, here I had to, it was supposed to be cis. This is cis, this is cis. Why am I writing that way? So the angle, you multiply by the exponent for that angle. You multiply by the exponent. Just like that. This is the concept of our d-moles. the modulus to the exponent, your argument, you multiply by that exponent. So with this, we can simplify because we do understand this, guys, the square root of what? Of 3. When raised to the exponent of 4, it's going to give us what? 9. So it is something that can be simplified. So that's 9. Cis, the angle, if we multiply these two, that was going to give us negative 141,056 degrees. Okay, so that is it. So if you are using 324, this guys was going to be a different value for that one. All right, it was going to be 4 times 324,736, like this. This is what you're going to get. You write that one. This is what you're getting. That will be your angle. If you choose to work with the positive, it's up to you. All right, so that was it. So those are the stages. We just need to figure out where which quadrant is it that we are having on our Argand diagram, where we are having the real and the imaginary axis from our Argand diagram. All right, then 2.32, it was just to simplify. This time we are not given to say in rectangular or in polar. Just simplify this. Okay, so that was 2.32. We are given j to the exponent of 3 minus j squared, everything over 2 j squared plus 5j to the exponent of 5. Okay, it's a straightforward question if you understand that j squared is equivalent to minus 1 from our complex numbers. This is a basic thing that you must put into consideration, that you must know. J squared is negative 1. So you use, or you try to make each and every j part be written in form or in terms of what? In terms of j squared. So there is j to the exponent of 3. How can we rewrite it? It is the same as j squared times j. Remember, this is to the exponent of 1. So if you're multiplying with exponents, where we know the value of this one, we know it. The value of j squared is what? Minus 1. So that's minus 1 times j, which is minus j at the end. Okay, so wherever there is a j to the exponent of 3, in its simplest form, it is the same as what? It is the same as minus j. Then minus j squared. J squared, guys, is what? Minus 1. So take note, there is a minus of the formula. The j squared on its own, it is minus 1. So there is minus of the formula, then the j squared. So that's another part which our memo did not consider. So we must be very careful there. Then there is 2j squared. Remember, j squared is minus 1. So it's 2 times. In a place where we see this, put minus 1. So 2 times minus 1 is what? Minus 2. Then 5, j to the exponent of 5. Let's see. J to the exponent of 5. How can we simplify this one in simplest form? Okay, there is a j squared. All right. If you take note, guys, it is j to the exponent of 5. So meaning to say there is remaining j to the exponent of 3 there. So we can also multiply by another j squared times a j. So j squared times j squared to the exponent of 4 times this one to the exponent of 5. So is it wrong for me to could have just written this one as j squared to the exponent of 2, as it is multiplying itself? So I can just say to the exponent of what? Of 2 times what? Times j. Is it wrong? It is one and the same thing. There is no effect in doing that. J squared squared, it's to the exponent of 4 times this j to the exponent of 5. Now our target is to have j squared. Why? Because we know it is equal to minus 1. So that was going to be minus 1 squared times j. Minus 1 squared in a bracket like that gives us a 1. So that's 1 times j, which is what? Which is j. So wherever we see j to the exponent of a 5, it is the same as what? As a j in simplest form when we see it. So this simply means it is the same as 5 in place of j to the exponent of 5. We just put what? We just put a j there. That is what it means. So you had to simplify from this. After that, you figure out, okay, what is it that I'm supposed to do that I'm having this, which is in simplest form? Okay, let's combine minus and minus. That's a plus. So that was going to be 1 minus j plus 1, which is the same as 1 minus j. Okay, everything over minus 2 plus what? Plus 5j. So we can rationalize our denominator by introducing a negative on the imaginary part. So it's a positive there. You introduce a negative. So it will be minus 2. You introduce a negative here. So it will be minus 5j. So this is the one that we're going to multiply our numerator and the denominator. Just like that. So this is it, guys. Let us expand our numerator. So the numerator in this case, these are 2 brackets. So that is why we're saying expand. So you need to multiply. 1 is going to multiply everything in the second bracket. The same thing with the minus j. It multiplies everything in the second bracket. Okay, so let's start with 1. So that was it. 1 times minus 2, which is minus 2. 1 times minus 5j, that's minus 5j. So we are done with the 1. We move on to the minus j. So it's minus j times this minus 2 minus times minus. That's what? A positive. So that's positive 2j. The minus j multiplies the minus 5 there. Minus to a minus, which is what? A positive. So that's positive 5j squared. J times j is going to be a j squared. Everything over what? For the denominator, guys, what is happening is that one is the complex conjugate of the other, introducing a minus on the j part. A plus bj like this. Its complex conjugate is given as a minus bj. And I said the product of a complex number to its complex conjugate gives us a real number, which is a squared plus b squared. Complex number to its conjugate gives us a real. So you just have to focus what is your a and your b. You square them. Add those. A squared plus b squared. So our a is what? Minus 2 is represented by minus 2. So that's minus 2 squared plus b squared. Our b, which is what? Which is 5. Guys, don't you're talking about the number to say the number there is 5. The number that we are seeing, the b, is 5. A plus b, a minus b. So the A, this one, as it is, this is the A. But as for B, take note, we are saying plus B minus B. So B is 5, not minus 5 or plus 5. B is 5, 5, 5. Take note there. So you square that number. So even if you make a mistake, guys, you take a negative, you square it. Guys, it's a square there at the end of the day. A square, it will give you a positive, so you don't see the effect. All right, so let's simplify the numerator. They are like terms to be considered. The minus 5j and the 2j, those are like terms. So you can consider combining these two together. So minus 5 plus 3. plus 2, that's minus 3, sorry. So that's minus 3j. And remember, I said j squared is what? Minus 1. So if j squared is minus 1, it means 5 times minus 1, which is what? Minus 5. So this is minus 5, everything over the denominator, which is minus 2 squared, that's 4 plus what? 5 squared, which is 25. Okay, 4 plus 25, which is 29. Okay, so this was going to give us, combining these numbers, negative 2, negative 5, that's negative what? Negative 7. Then the part of j is what? Minus 3, j as it is over what? 29. 4 plus 25, that is what? 29. So everything is over 29. So we can separate it. The real on its own, the imaginary on its own, or you can even just leave it as it is. They will mark you. So that's minus 7 over the denominator. The j part, minus 3 over 29j, as it is. We are not given any further instruction to say, if this one in polar form, or they just say simplify on 2.3 to no further instruction. But guys, for 2 marks, they give lesser marks for this J notation, because guys, they assume you know, you treat it as a basic topic. They assume that you're gonna treat it as a basic topic. Anyways, this is what you had on 2.3, 2.4. Determine the arguments and the modulus. So remember, if we write r cis theta, we have our modulus and the argument. So we had to simplify this so that we are left with a single term of a polar number. A single term. So what is the case? There we are given z, which is equal to 2, the angle of minus 30 degrees. 3, the angle of 75 degrees, everything over 4. Then the angle 36 degrees. And we have got 5, the angle being what? Negative 21 degrees. So remember, a product in polar form, r angle of theta multiplied to another r angle of theta. You multiply the numbers in what? That we are given as the modulus r1, r2, and the arguments, you add them, the angles. So this is our condition. The 2 and the 3 are supposed to be multiplied together. 2 times 3, that's 6. And the angles, you add minus 30 plus 75. You add the angles. The same with our denominator, because it's under a product. 5 times 4, which is what? Which is 20. Then for the angle, we add again 36 plus minus 21. Okay. So this is it. Let's simplify and have a single term. So it's going to be 6 cis 45, all right? 75 minus 30, that's 45 degrees. This is 20. Since the angle is going to be 36 minus 21, which is what? 15 degrees. A division in polar form is the one that we are having. What is the condition? This time you are going to divide your moduli. Arguments, subtract them. So that is the condition for a division. So it's going to be r1 over r2, but the angles you subtract, theta 1 minus theta 2. So this is what we were going to have at the end. 6 over what? Over 20. But as of the angles, you must subtract them. Theta 1 minus theta 2, so that's 15. 45 minus 15, I mean. Okay, so that is it. With this, we can tell what is it that represents the modulus and the argument. So 6 over 20 is same as 3 over 10 or 0, 3. Then you combine these angles, 45 minus 15, that's 30 degrees. So this is it. This is our r, this is our theta. So the question was to determine our modulus and our argument. So therefore, our modulus is what? 3 over 10 or 0, 3. Our argument is what? 30 degrees. That's the angle that you're given. So that is how these questions can be given, as you must have a single term in polar form. That is where you can properly see this is my argument, this is my module in polar form. So apply all the basics, all the laws, all the concepts that you understand on your what? On your polar, which is your polar form, and also yeah, that's it. Those are the basics actually that you're gonna need. There is no exponent, so the DMOVs, just forget about it when it is like that. On 2.5, there is an equation that you're given to solve for x, a quadratic equation. 2x squared plus 4x plus 4 is equal to 0, which we can even divide by 2. Reduce it. It's allowed, guys. It's allowed. When it is an equation, you can divide it. Factorization is the one that you are not allowed to do this. But division, I mean, equations, you're allowed to reduce the equation as long you are not dividing by x. You are dividing by a number. It's not an effect. Using the quadratic formula, we can solve this equation. As we can see, guys, there are no factors here. Two numbers that you multiply, they will give you a 2, but you add them, you get a 2. It's not possible, because the two numbers that you multiply to get a 2 is 2 and 1, or maybe minus 2 and minus 1. Those are the only numbers. But where is it that you can add on these numbers, then you get a 2? It's impossible. So meaning to say factorization is totally out. You cannot do factorization. So that's why we are opting for the quadratic formula. And in that case, it is part of our complex numbers. So we know what exactly are we expecting to have the J notation. So our x is equal to, so this is our A, B, and C. Minus b, that's minus 2 plus or minus the square root of b squared. 2 squared minus 4 times a times c, which is 2. Everything over what? 2a, which is 2 times 1. So, like I say, do not be tempted to use your calculator at once to simplify everything. No. Simplify stage by stage. What is under the square root? These numbers under the square root. What are you going to obtain from there? Do not put the square root. The numbers only. 2 squared, okay, minus 4 times 1 times 2. As we can see, we are obtaining a negative, which tells us that we cannot determine the square root of this. So thus the issue or the idea of our complex numbers, the J notation to be used, the square root of minus 4, it is the same as square root of minus 1 times the square root of 4, where the square root of minus 1 represents a J, and the square root of 4 is what? Is 2. So meaning to say, in this case, it was going to be minus 2 plus or minus the square root of what? Of this minus 1 times, which gave us what? Which gave us j2 or 2j. It's up to you. You can just write as what? As j2. Square root of a negative j. Square root of 4, 2. Already the plus or minus is there. Everything over 2. You're done. This is it. This is what we have. So writing in the form of a plus or minus jb, we can divide, guys. Each and every term, 2 is common. Plus or minus j2 over what? Over 2. So this can cancel, this can cancel. So it's minus 1 plus or minus j1. This is These are the answers for x. There are two possible values. The -1 plus j1, which is just j, or the -1 minus j1, which is simply minus j. Those are the two possible solutions that you can actually have at the end. So as you can see, guys, they'll be playing around with you. And remember, they are good at that. They are good at that. They just want to test you. So you use your calculator at once. Those guys who want to use their calculators at once. That is where now you'll be tempted. Then you say, question 2.5, it is having an error. No, it is because the negative under the square root. All right, question 3. That's another question which they just took. I think they just took from another memo which they used. I don't know which year was it. They did not even answer the question that they asked there. All right, question 3.1. Solve this equation. 2 cos squared x plus the cos of 2x minus 1 is equal to 0 for this interval 0 to 270 degrees. It is a quadratic equation that we can see under our trigonometry. But for us to solve this equation, we must have like terms. Guys, in trigonometry, cos x, cos squared x, cos 2x, cos 5x, they are not factors, these ones that they are not like terms, I mean, that we can say cos 2x and cos x. No, those are not like terms. When we talk about like terms, guys, these are the ones that are corresponding to each other. If it is cos x, let it be cos x. It is the same even for a quadratic equation. You cannot say you're solving a quadratic equation of x squared plus 2y minus 1 is equal to 0. This y here has to be written like this x. It is the same thing with our cos 2x. It is just like this is y. This is x squared. You have something that has got y and something has got x. It is different. So the easier way is to work with the y, the cos 2x. Let us convert it to the cos of x. It is possible, very, very possible for us to convert this. Our double angle identities, remember, from our double angle identities, which states that the cos of 2x can be written as cos squared of x minus the sine squared of x, also 2 cos squared x minus 1, also 1 minus 2 sine squared x. Of these three identities, which one is the best? Is the best. We cannot take the cos squared and sine squared. Guys, we do not need that to have cos and sine at the same time to complicate our question. Second one, it is in terms of a cos squared exactly what we have there. The third one, it is in terms of a sine. Why complicating bringing a sine where there's a cos? You're complicating the whole thing. So the best is this one, 2 cos squared minus 1. Let's put it in place of cos 2x. So it was going to be 2 cos squared x plus, in place of this cos 2x, we substitute with its equivalent, 2 cos squared x minus 1. Guys, it's a positive, so there's no need for even new opening brackets there, all right? After that, do not forget there is what? A minus 1 here already given. So that's equal to 0. We have an equation which has got cos squared, cos squared. These are like terms. These are similar things that you can work with. from our addition, we can consider those coefficients and add. So 2 plus 2, that's 4. Cos squared x minus 1, that's minus 2, which is 0. So take the minus 2 to the other side of the equation. That was going to be equal to 2. Then we can divide by what? By 4 to get rid of that constant. So that's cos squared that we are having there, which is equal to 1 over 2. Introducing the square root so that we get rid of what? Of the square that you're given there. So the square root of cos squared x is going to give us the cos of x, which is equal to the square root of this plus or minus square root of 1, it's 1. Square root of 2 is the square root of 2. You cannot determine that one. So you can even just leave it like that, plus or minus square root of 2. Guys, it is the cos of x equal to two possible values there. Two possible values. Trigonometric equations. Remember the reference angle concept, because cos can be positive, can be a negative. Remember I talked about this from this cast. Cos can be found being positive in these two quadrants, for all and for cos. Positive. Being negative where there's a sine and a tan in these two quadrants. So those are the quadrants that we are going to use and consider to find our solutions. But like I said, in each and every quadrant, there is what? A reference angle. In each and every quadrant, there is a reference angle. So what is that reference angle? Because the reference angle is not affected to say there was a positive here, there was a negative here. No, the reference angle is not affected by that. So it's going to be arc cos of the positive value. You ignore the negative sign that you're given there. This was going to give us the reference angle, which we are going to use now for each quadrant, which was what? 45 degrees. This is the reference angle that we are going to use for each quadrant. To analyze our final solution from this here, because our cos can be positive, can also be negative. So for positive values, all right, when this cos is positive, we have the first quadrant. Remember, in the first quadrant, guys, your final solution is equal to the reference angle. In the second quadrant, your final solution is 180 degrees minus the reference angle, where in this quadrant, we add the reference angle. And in the fourth quadrant, 360 degrees minus what? The reference angle. So for the first, our final solution, which is x, is equal to the reference angle. This is for the first quadrant. And our reference angle is what? 45 degrees. So x is 45 degrees, which is within our interval from 0 to 270 degrees. It is within the interval. So meaning to say, we need this solution. Then we move on to the fourth quadrant, where cos is also what? Where cos is also positive. There it is supposed to be 360 minus the reference angle for the fourth quadrant. So our x being 360 degrees minus the reference angle, guys, we're going to subtract the reference angle, which is 45 degrees. That was going to give us 315 degrees, which is more than 270. We do not need that. The interval less than or equal to 270. So this is out of interval. Okay, so we're done for the positive. For the negative value that we are given, where is it that our cos is negative? That's the second and the third quadrant. So those are the other solution, plus or minus, take note. So we are on a condition where this cos is negative. Second and the third. So in the second quadrant, 180 minus reference angle. All right, so those are the ones. So we've got the second quad. Our x was going to be 180 degrees minus the reference angle, which is 45 degrees. 180 minus 45, which is 135 degrees. Then the other one is in the what? In the third quadrant. And in that quadrant, 180 plus what? 180 plus our reference angle, which is 45 degrees. You're going to get all the possible solutions in that interval. That was going to give us 225 degrees. These angles, they are in within 0 to 270 degrees. 0 to 270 degrees. They are in within the given interval. So therefore, our x, which is satisfies this interval that we are given, starting with the least value, was going to be 45 degrees, or our x can be 135 degrees, or it can be 225 degrees for values that are in within the given interval from 0 to 270. That's how they can play around with us. That's how they can play around with us. The interval. You just answer everything from 0 to 360. No, answer the question, guys. Answer the question. So that is what we had. And 3.2, we are given to determine the value of 1 over the cosec of what? 75 degrees. And in doing so, you are not supposed to use a calculator without using a calculator. All right, so let's see. 1 over the cosec of 75 degrees. Remember, 1 over sine theta is the cosec of theta. So 1 over cosec is going to give us what? A sine. So this one is simply the sine of what? 75 degrees. Without using a calculator, which concept can we use? How can we split the angle of 75 degrees into two parts? Either by adding or by subtracting two angles that you can use. And those angles, they are supposed to be special angles because no calculators. Remember, 30 degrees, 45 degrees, 60 degrees, and also the 90 degrees. So which one? 75, 30, and what? And 40. If I add these two, 45 degrees, add it to 30 degrees, I'm going to obtain what? 75. It's a combined value. So this represents the sine of A plus B from our compound angles identities. The sine of A plus B, remember, it is equal to the sine of A cos of B plus the cos of A sine of what? Of B. So meaning to say, if this represents our A and this represents our B, it was going to be the sine of A 45 degrees, the cos of B 30 degrees, plus the cos of A, which is 45 degrees, times the sine of B, sine of what? 30 degrees, just like that. With this, we can use our special angles, which I said, guys, nothing is special about those special angles, guys. Because I can even write it by head here without even drawing these diagrams, guys. I don't need to have those diagrams. This can have it by head. So nothing is special. Just even use your calculator there. Nothing is special. Use your calculator. You'll be wasting your time there. All right. For the sake of revision, let's just have it. But for exam purpose, guys, do not even waste your time to say they say do not use a calculator there. No one is going to even understand or know that you have used a calculator. Just apply it direct. But anyways, the sine of 45 can be determined from the angle of 45. Remember, sine opposite over hypotenuse, 1 over the square root of 2. 1 over square root of 2, guys, remember, is the same as square root of 2 over 2. We can simplify by rationalizing the denominator. So in simplest form, that's square root of 2 over 2 times the cos of 30. Cos of 30 adjacent over hypotenuse, square root of 3 over 2 plus, remember, cos 45 and sine 45, they are equal. So what you wrote for sine 45, it is the same for cos 45. Square root of 2 over 2 times the sine of 30 opposite over hypotenuse, 1 over 2. Remember from your ratios, SOHCAHTOA, opposite over hypotenuse. So it's 1 over 2. Just like that, we are done. We just need to simplify everything. Remember, multiplication, numerator to the numerator, square root of 3 and square root of 2 multiplied together. That's square root of 6. Square root of A times the square root of B is the square root of AB. So you multiply 2 times 3, which is 6. 2 times 2, that's a 4, plus square root of 2 times 1, it's the square root of 2. 2 times 2, that's a 4. So this is what you're going to have. As we can see, same denominator throughout. So just combine the numerators together, square root of 6 plus square root of 2, everything over what? Everything over 4. There's no need for you to factor out this and that. These two also cannot be added. They are different numbers under the square root. So don't be tempted as an individual to end up adding numbers that are under the square root. As long they are not the same, you cannot add or subtract those numbers. So you see, guys, they'll be playing around with you. Easy and straightforward. You just have to be very, very careful. Revise all basics. For this to be easier, guys, revise all section of your syllabus, every section. You'll see that they will repeat. There is no way. You're not going to have a new question paper in your syllabus. It will be a repetition. They don't have time for that, those guys. So do revise as many question papers as you can. Number 3.3, simplify as far as possible. Okay, let's look into this. Sine 90 minus theta. All right, remember from the complementary concept, the sine of 90 degrees is already the one that we are supposed to write. So guys, rewriting it's the rest of time, because this one you're just supposed to know it, isn't it? Cos 90 degrees minus theta is the same as what? The sine of theta, those ones which are complement, to say this is theta. I mean, this is 90, this is theta, this is 90 degrees minus theta. They have a relationship. So that's the relationship. Sine changes to cos. So it's cos of theta times 180 plus theta. We can reduce this one. Remember, 180 plus theta is in the third quadrant. That is where we've got our theta. So 180 plus theta is in the third quadrant. And in that quadrant, cos is a negative from the cast concept. Cos, it's negative. So it's going to be negative cos of what? The acute angle, cos theta. Plus, they is separated by a plus. Then we've got the tan theta. Tan theta is already in simplest form in terms of having theta, but tan on its own, it is the sine over cos. Okay, cos in simplest form, just leave it like that. Sine theta minus 180 from negative angles. Remember, guys, I said this is the angle that we have in the what? In the third quadrant. That's our theta minus 180 degrees. Theta minus 180 degrees is the same as minus 180 degrees minus theta, that angle. So it's found in the third quadrant as a negative. It's a negative angle. This one, it's a positive angle. The way that we took the direction, this one, negative. So what is important, guys, it's not about being negative or being positive. What is important is the quadrant where it lies. It lies in which quadrant at the end of the day? In the third quadrant. So from our cast concept, this is the quadrant for a tan, not a sine. So a sine is what there? A sine is negative. So it's going to be negative sine of theta. All right, so this is it. Let's simplify and see cos times negative cos. It's going to be negative cos squared of theta. All right, this is same as over 1, so this can cancel. All right, then we've got plus and minus. That's a minus. Sine times sine is what? Sine squared theta. Okay, there is a double, sorry, the Pythagorean identity, which is hidden here. If we just factor out a negative, you can see that it is visible now. Factor a negative, so that's negative times what? This whole thing represents 1. So that's a negative 1 at the end of the day. So you see, guys, trigonometry is one of the, in fact, trig, derivatives, integration. Know the basics of those ones. You enjoy those topics, guys. In fact, mathematics N4 is supposed to totalize. I'm supposed to totalize this one, guys. 98% for final exam. With all this information that you have, it's a lot. I do not want to lie, guys. You have everything that you need to score those marks in your final exam. All right. On question 3.4, it was to prove that this here on the left-hand side, it is equal to, it was negative square root of 2 over 3. That was the question. So I'm going to take the left-hand side, simplify the left-hand side, and see what you're going to have. Sine 315. Let's reduce this one. 315, which quadrant? Third. It's more than 270. 0, 90, 180, 270, 360. It is more than 270 degrees in the third quadrant. So that's something like this, 315 degrees. So you ask yourself, guys, in the fourth quadrant, we have 360 degrees. So it was supposed to be sine 360, sine 360 degrees minus something to get this 315. So what is that something? You just subtract it from 360. 360 minus 315. You know that something that was supposed to be subtracted, 45. So 360 minus 45 gives you what? 315. So it is same as sine 360 minus theta, theta being our acute angle there. So what are we going to have at the end of the day, guys? In this quadrant, sine is what? Negative. So that's negative sine theta, negative sine 45. Our theta is what? 45. So this whole thing that we are seeing, sine 315 is what? Negative sine 45 degrees in simplest form times the tan of 210. 210, that's less than 270, more than 180, but less than 270 in the third quadrant. So it was going to be somewhere there. This whole angle, the whole of that angle be 210 degrees. What is the acute angle in that quadrant? What is that acute angle? How do we notice it? 210 minus this straight line 108. 210 minus 180, what do we get? 210 minus 180 is 30 degrees. So the acute angle is 30 degrees in between. But know the presentation. How do you present these angles in the third quadrant? It's 180 plus what? 180 plus theta, imagine. Remember that. So it was supposed to be written as tan 210 plus 30 degrees. I mean, 180 plus 30 to get 210. That is how they were supposed to write it. That is how we were supposed to have it, where theta is 30. So tan in that quadrant is a positive. So it was going to be tan theta, which is what? Tan 30. Or theta is 30. So that's tan 30 there. Then we have got the sine of 190. 190 is also the same, guys. More than what? More than 180. So it was going to be in the third quadrant. So 190, let's say this is 190. It was going to be 190 minus 180. There's a difference of 10. So it was supposed to be tan, I mean sine, not tan, because this is sine. So it was supposed to be sine 180 plus 10 to get that 190. So sine, guys, in this quadrant, it is the quadrant for a tan. So sine is what? Negative. So that's negative sine of theta, which is what? Which is 10 degrees. Negative sine 10. Just like that. Just like that. Just like that. Everything over what? The cos of 100. 100 in the second quadrant, isn't it? In the second quadrant, because this is 90. So 100 was supposed to be somewhere there. Let's say this is 100. What is the acute angle in that quadrant? It will be 180 minus 100, which is what? 80 degrees. 180 for the straight line. So this is our acute angle. So remember, in the second quadrant, your angles are written as 180 minus what? Minus theta. So it was supposed to be cos 180 degrees minus theta, which is 80 degrees, to give us what? This 100. 180 minus 8 is what? Is 100. But remember, the quadrant that we are dealing with, the quadrant for a sine from our cast. This is for sine. So cos is what? Negative. So it was going to be negative cos of the acute angle, which is what? 80 degrees. So that's negative cos 80. Okay. Times the sine of 120. Oh, already 120 is just same as 100, guys. It's only that we are dealing with what? A sine. So 120 is the same as sine 180 minus what? 60 to get 120. So it is the quadrant of a sine, so therefore it will remain as a what? As a positive. Remember, of what? Of the acute angle. Sine is positive in the second quadrant. So that is it. It is, guys, what can I say? I don't know what can I say. Play around with your quadrants. That is what I can say at the end of the day. Know your quadrants, play around with those quadrants. That's it. And also applying your special angles. Like I said, there's nothing that is special about these angles, guys. Sine 45, it is the same as square root of 2 over 2, just like previously we saw this one. Okay. Minus square root of 2 over 2 times the tan of 30, which is square root of 3 over 3. So square root of 3 over 3, okay, times the sine of minus 10. It's not a special angle, so let's just rewrite as it is. Minus cos 80, it's not a special angle again, but we cannot repeat this one again. Let's try to rewrite it as a sine. In form of a sine, is it possible? 80 degrees, remember, is same as 90 minus 10. So it is the same as we've got cos 90 degrees minus 10. So this, remember, cos 90 degrees minus theta is the same as what? The sine of theta. So our theta is 10. So it's going to be sine 10. But there's a negative, take note here, which was already there. So it's going to be negative, which was already there. But cos 80, this one is same as what? Is same as sine 10. Just like that. Times the sine of 60 degrees. Remember from our special angles, 60 degrees, it's going to be opposite square root of 3 over 2. Okay, remember that's square root of 3 over 2 there. Okay. Anyways, let's see what we are having, because the sine of minus 10 and this one can cancel. Also, if we check what is happening in the numerator there and the denominator, there's something that is common there. If we check properly, square root of 3 over 2 in the numerator, square root of 3 over 2 in the denominator. They can cancel. One is in the numerator, another one is in the denominator, so it can cancel. So the denominator, guys, we are left with a 1. So it's this in the numerator divided by 1. So it simply means it was going to remain as the numerator as it is. Square root of minus square root of 2 over what? Over 3. Because it is just like over 1, guys. Over 1 does not affect x. Over 1, it's x. 2 over 1 is 2. So minus square root of 2 over 3 is going to remain also as it is. So that is what we're being asked to prove, exactly what we have on the right hand side. Remember, this is the proof that the left hand side, if you simplify it, it must give you exactly what you have on the right hand side. It's a proof. It is just like those questions that we used to have them, but they are like you're being asked to simplify. If you still remember, there are questions that you are being asked where you'll be asked to simplify. It is the same type of a question. The only difference that we are having on our question this time is that we have the answer. They gave us the answer. The answer is, so just to show us that if you simplify, you are going to have that same answer on your presentation. Okay, so that is how these questions will be given, as we just have to be careful. So on question number 4, we are now given the part of our derivatives. All right, so that was 10 marks for the first part. 4.1 to use our derivatives in attempting this question. It is an application of our derivatives. All right, so they are saying use differentiation to calculate the coordinates. All right, so you must calculate the coordinates of the turning points. All right, the points of inflection, and also distinguish between the maximum and the minimum turning points by using second derivative in order for you to distinguish that. So there we have our f of x. All right, our 4.1, we are given our f of x as x cubed minus 2x minus 4. Guys, it's just a repetition. They repeat these questions, guys. All right, so remember, for our turning points, the first derivative must be equal to 0. So what we are going to look for is our first derivative. So that is with respect to x, we're going to drop the exponent, we subtract 1. So if we drop the exponents, that's 3x, subtract 1, that's going to be 2. This one is a linear, so it's just going to be minus 2. A constant, that's a 0 there. Okay, so there's nothing that we're going to have. So this is our first derivative. It must be equal to 0. That's an equation. 3x squared minus 2 is equal to 0. Solve for what? Solve for x. Just like that. It's a quadratic equation, so you can take the 2 to the other side, as we do not have the part of x. It's just x squared. So you can take this to the other side of our equation. So that was 3x squared is equal to minus 2 to the other side is going to be positive. Divide by 3 by 3. So that's x squared is equal to 2 over 3. So to find our x, definitely we had to introduce the square root to get rid of that square that you're having there. So our x at the end of the day, because we're dealing with the square root, so that's plus or minus. You can leave it like that as it is. You can simplify this on our calculator. That was the square root of 2 over 3. All right, square root of 2 over 3. So that is going to give us 0.816 to 3 decimal places, 0.816, or you can just use it as a square root as it is. So that is it, guys. These are the values of x at the turning point. So therefore now our turning points, all right, so we have got the first one where x is a positive 0.816. So you substitute the value into your f of x, your original equation, to determine the value of what? That's 0.816 to determine the value of y. So I'm just going to store at a. Okay, so that's it. It's going to be easier for me to just recall that one. So that's x cubed. So I'm just going to say recall a cubed. Okay, minus 2 times, okay, let me put this one down, minus 2 times the recall of a minus 4. So simplify this, that was going to give us negative 5 comma 0.886 and so on to 3 decimal place. That's it's going to be 0.89. Oh, just fix your calculator, guys. Go to shift, set up, fix your calculator, press 3. It's going to give you answers to 3 decimal places, all right? So that's negative 5,8, 5,08000089. Okay, so that's 0.89. That's our first turning point. And the second turning point when x is being what? A negative there. When our x is what? So that's our second turning point. When our x is negative 0.816, we're going to have the value of y. So just like the previous case, we can take negative 0.816. You store it. So I'm just going to store it at what? At a, like that. So I can press this arrow button so that I have my previous expression. As you can see, this was our previous expression where our answer was being stored in a. Since we have stored another value which is different in that a, is going to give us the answer for the value that we just stored in our a, which is this one. So that was going to give us what? Negative 2,911. Just like that, okay? So these are the turning points. Before we move on to the points of our inflection, let's distinguish, guys, between these. Is it maximum or minimum? These 2 points. Which one is the maximum? Which one is the minimum? What is it that we must consider for us to distinguish? So to distinguish, we are going to need the minimum. We are going to need to specify, is it minimum or is it maximum from the second derivative. From the second derivative with respect to x. When that second derivative is greater than 0, therefore we are dealing with what? A minimum turning point. When that second derivative with respect to x is a value which is less than 0, we are dealing with a maximum turning point. So let's have the second derivative. Remember, from our first derivative here, 3x squared minus 2, our second derivative with respect to x, drop the exponent, subtract 1, so that's 6x if we subtract 1. Okay, minus 2 is a constant, so its derivative is what? Is a 0. So this is our second derivative. So for the first turning point, our x value is what? Remember, this is x versus y. So you substitute that x value that you are given, 0.816. So that's 6 times in our second derivative, 816. Substituting this, it was going to give us a positive. Even if you do not simplify it, guys, you can see positive times positive is what? Is a positive, but it was going to be 4,896, which is a positive. That's a value greater than 0, positive. What gave us a second derivative being a positive? that value of x, where we took it, is from what? A minimum turning point greater than 0 positive. So our first turning point, this one, it is, or it represents, a minimum turning point. That is what it means. You do the same thing for the second point. Already the second derivative is there. You just have to substitute the value of x for the second turning point, which is negative 0.816, into the value of x here. It was going to give us a negative. All right, so that was going to give us negative 4.896. A negative less than 0, that's a negative value. So it means from where you took that x value, which gave us a negative for the second derivative, that point is a maximum turning point. So therefore, guys, the second turning point, because it gave us the second derivative, which is a negative, it means it represents what? A maximum turning point. Remember, I explained this one on our introduction. So that was it. We also have on our question, it was the points of what? Of inflection. So for the point of inflection, guys, the second derivative is equal to 0. For the point of inflection, the second derivative must be equal to 0. Already the second derivative, we have it. Let's just equate it to what? To 0. So if 6x is equal to 0, solve for what? For x. As you can see, there's only one unknown. So we solve for x. It's an equation, this one. So divide by 6 by 6, x is equal to 0. At that point of inflection, x is 0. So what about the value of y? If we substitute into our original equation there in our f of x, the y value, guys, was going to give us a negative 4. Properly, we can see that one. So that's as a point of inflection. Our x being what? 0. Y is negative 4. Just like that. We substituted into the original f of x. So that is how we can be given these derivatives. 10 marks. 10 marks for that. Just like that. They will be testing you guys. Do you know the concept, this and that? So you see, if you have all these basics, it will be a walkthrough type of a question when you are in exam. Then on another question, which is 4.2, we are given this. Y is equal to the square root. That is the square root of what? Of cot x. From that one, they are asking us to differentiate using the chain rule. All right, so y is equal to the square root of cot of x, which is the same as the cot of x to the exponent of what? Of a half. Remember, the chain rule or function of a function is where we introduce u as another function in place of x, the one that is complicated, raised to the certain exponent. So if we say let u be equal to the cot of x. So therefore, y is equal to what? In place of this, we're going to put u. So that's u to the exponent of a half. So our formula from the chain rule states that the derivative of y with respect to x is equal to dy du times du dx. So we need the derivative of y with respect to u, of u with respect to x. So those are the ones that we have here. So that is it. The derivative of u with respect to x, if you are differentiating a cot, remember from your formula sheet, that's negative cosec squared of x. And the derivative of y with respect to u from our power formula, drop the exponent, then subtract 1. So that's minus half. So this is it. Substitute into the formula, you are done. So that is the derivative of y with respect to x, dy du. That is this one, 1 over 2 u to the exponent of a half. All right, minus half, sorry, times the derivative of u with respect to x negative cosec squared of x. So this is it, or this is what we have, which must be written in terms of x. But trying to simplify this is same as over 1. And also we know that for a negative exponent, it's going to be written as 1 over u to the exponent of a half. And we understand, guys, exponent of a half is what? The square root. So that's the square root of a u. So meaning to say this was supposed to be written as 1 over 2. This one is now written like this. So it's 1 over square root of u. So it's simply the square root of u like that. Times negative cosec squared of x. So this is it. We can multiply. And also remember u is equal to what? To cot. So in place of u, you can substitute that one as the cot of x. As you are multiplying the numerator to the numerator, the denominator to the denominator. So multiply the numerators together. Negative cosec squared of x over the denominator, which is this one times this one is 2 square root of u, where our u is what? The cot of x. So questions can be of that nature. Questions can be of that nature. Finally, you must have x on your answer. It must be in terms of x, derivative of y with respect to what? With respect to x. Just like that. Guys, is it that difficult? No. For you guys under this channel, it's not supposed to be this difficult. Maybe if you're new, but for those who have been watching the videos, introductions, yeah, it can be easier because we have these introductions. 4.3, okay, with respect to y, differentiate. That's x with respect to y. Let's start. This is, okay, so there I'm just going to write the answer, guys. The derivative of x with respect to y is, okay. Let's see here, 1 over this, 1 over the cube root of y is the same as 1 over y to the exponent of a third, which you can take up and written as y to the exponent of minus a third. Before we differentiate, we are just rewriting. Now let's differentiate. We drop the power, so that's minus a third, then we subtract 1. So minus a third minus 1 is going to give us minus 4 over 3. So that's minus 4 over 3. So we have differentiated here. So let us rewrite as minus. Remember, I talked about this 1 over, guys. So it's minus 1 over 3 y to the exponent of 4 over 3, which we can write as 3. Remember the denominator into the root sign. So it's the cube root of y to the exponent of what? Of 4. So you rewrite into a way that you can differentiate from the basics or your standard derivative. Then you differentiate just like that. All right. Moving on to the second one, that's a negative 1 over the cosec of 2y. So 1 over cosec is what? The sine. The sine. So it was going to be negative sine 2y, this one. Negative sine 2y. Then we can differentiate. So remember, sine, guys, changes to a cos. So that's the negative here already on our answer, this one. But sine changes to a cos. So it's going to be 2 cos 2y. Okay, so that's it. So that's negative 2 cos 2y. The negative is this one, guys, that was here. We just took it on our answering of the question. Okay, the next part, it is the ln of y. It's already in simplest form. Remember, ln is 1 over y if you differentiate it. Okay, it's a plus. Where am I getting the negative? It's a plus, that one. All right, there is minus e to the exponent of minus 2y over what? Over 4. So remember the derivative of e to the exponent of a certain part, if it is with respect to y, like what we are given, and we are given f of y there, it is e to the exponent of f of y. It remains as it is, but you must find the derivative of that function. So in this case, this here remains as it is, e to the exponent of minus 2y over 4 times the derivative of this. What is the derivative? Or just multiply by that constant negative 2. So that's it. It's going to be over 8. E to the exponent, this one cancelled with this one. So it's e to the exponent of 3 minus 3y over 8, 4 times 2. So that's it. It was a negative. Remember, the negative cancelled, so it's now a positive, this one. So it's now a positive here. E to the exponent of minus 3y over what? Over 8. So that's it. You just have to check each and every part, like rewrite, then differentiate. This one already in simplest form, 5, that is 5 to the exponent of 3 pi y, like this, over what? Over 2. The 1 over 2 is a constant. This 1 over 2 is a constant. So remember that if you are differentiating these formats I talked about it, guys, let me just put the x that you are used to. Ka to the exponent of f of x is gonna be k times the first derivative of that. You differentiate the function, then a to the exponent of that function remains times the ln of a. So in our case, our constant, it's 1 over 2 times the first derivative of y there. We are dealing with y, so if we differentiate, it's going to be what? It's going to be 3 pi times a, our a to the exponent, 5 to the exponent of what? 3 pi y times the ln of a. Remember, our a is 5, so it is the ln of 5. So this is it. This is it. Okay, so we can just write this one is over 2, so you can just rewrite this one over 2. So that's 3 pi 5 to the exponent of 3 pi y times the ln of what? Of 5. Everything over 2. Okay, which is okay, which is okay. We do not have another part like this one, so let me just erase. All right, let's move on to negative pi, negative p times pi to the exponent of 0. Everything to the exponent of 0 is going to give us 1. So the derivative of 1 is a constant, guys. That's a 0, so that's minus 0 there. Okay, p, 6py with respect to y, so you're just going to take the constant that is multiplying y there, which is what? 6p, the coefficient of what? Of y. It's a linear, remember. So a linear, you do not, guys, you do not work with a lot of things. Just consider that part. So for the basics, for answering the question paper, guys, we are not doing introduction here. We are doing the question paper. For answering the question paper, this is what you just needed. Rewrite each and every term for each, then compare with the derivatives from the formula sheet, okay? You won't go wrong. On 4.4, we are given by the quotient rule. Differentiate this by the quotient rule division. Y is equal to the cot of x. Remember, if we are given y is equal to u over v, the derivative of y with respect to x is going to be v, the first derivative of u, minus u, the first derivative of v over v squared. So we must have a fraction in order for us to use the quotient rule. So, but there we do not have a fraction, it's just a single term. So cot of x, can it be written as a fraction? Can it be written as a fraction? Yes, from what? Cos over sine. So that's it. We are done. Knowing this, guys, we are done because the formula states that if you've got u over v, we can apply the quotient rule, which says that it's going to be v our denominator, the sine of x, times its derivative, the derivative of the derivative of the numerator cos. You differentiate cos, remember, from your formula sheet, that's negative sine x, minus u as it is the numerator cos of x, times the derivative of v, the denominator, its derivative. The derivative of sine is what? It's cos. Just like that, over v squared, which is the denominator squared. You square it. You square the denominator. Simplify until you have got an answer, which is an exact form. All right, so that was it. Negative sine squared. If you multiply this, negative sine squared of x, negative to positive, that's negative cos squared of x, everything over the sine squared of x. Remember, we had a similar question in this question paper where the negative was common, and when we factored that negative, we remained with a Pythagorean identity, which we are used to. The sine squared plus cos squared, which is equal to what? To 1. We know this. So it's going to be negative 1 over what? Remember, there's a negative there, over sine squared of x. And 1 over sine, it's cosec. So when it is sine squared, it will be cosec squared. But remember, there's a negative, so that's negative cosec squared of x. And it truly gives us the exact thing that you're given from the formula sheet. Remember, from your formula sheet, you're given the derivative of a tan, which is what? Minus cosec squared. So that is just proving, it is just like proving to say, truly, the derivative of cot x is equal to what? Minus cosec squared. But there they said use the quotient rule. So you follow the concept of the quotient rule until you get your final answers in exact form. On question 5, integration, just like what we saw on question 4, there was a question on derivatives, which was for 7 marks, differentiating each term. It is the same even here for integration. They want you to integrate each term, 5.1. So have your terms in simplest form, then you can integrate. So I'm just going to write the answer, guys. 3 over sec 1 over sec, it's what? It's cos. So this one, 3 over sec was going to be 3 cos of 4x. We are just rewriting. Then let's integrate it with respect to x. Remember, the integral of a cos, it is sine. So it is sine. So it is 3 sine of 4x. But remember, guys, it's integration. Always divide by what? The constant here, the coefficient of x. What is the coefficient of x? It is 4. So, guys, this one, we're done. We're done, isn't it? We are done. So you just have to rewrite, then integrate. This one was direct and straightforward. So as for trig functions, guys, they are direct because we have got those integrals in the formula sheet. And if you know, even if you know them by head, just write the answers, all right? Let's move on to this one. This type, we dealt with this on derivatives. Also on integration is there. The integral of k a to the exponent of f of x with respect to x, it's ka to the exponent of f of x over the derivative of that f of x times the ln of a plus the constant. So in our case, it is negative 7 times 5 to the exponent of 3 pi x. So that's it's gonna remain, guys, the part that we are integrating here. It's just gonna remain as it is. That is under the integral sign. So it's just gonna be negative 7, 5 to the exponent of 3 pi x over what? The derivative now of f of x. So if we differentiate this, it's gonna give us 3 pi times the ln of a. Our a is the base. So it is the ln of what? The ln of 5. Just like that. So here, it was a direct question. Also, it was a direct question. If you have got these basics of your integrals, Okay, we have got part of your exponents there. Can apply this one. Do you have another one of this nature? We do not have, so let me just cancel it. Let me just erase it. All right, then there is, okay, take the negative up, guys. It's 9 over e to the exponent of minus 3x. So take the negative up, it's going to be positive 3x. Then integrating this, it remains, this one, it remains e to the exponent of 3x, but you must divide by what? Coefficient of x, 3. So it's going to give us what? 3 e to the exponent of what? 3x. You have integrated. So you have integrated, so that's plus 3 e to the exponent of 3x. Okay, then we have got the pi x to the exponent of what? X to the exponent of minus 3. All right, so that one is already for x. Remember, for x, it's gonna be a condition where you add a 1. So if you add a 1, it's gonna be x to the exponent of minus 2 over that new exponent minus 2. So that was gonna be negative pi. We can even take this one down. So it's gonna be over 2x squared. If we take it down, it's gonna be x squared there. Okay, then minus here is this one. Okay, so that's it. That's it. That's it. That's it. That's it. That's it. Then this one, remember guys, 1 over x gives us what? Ln. So it's gonna be minus 3 pi, the ln of what? The ln of x. Then cosec squared is the reverse of that tan that you proved. Remember there you said if you differentiate a tan, you get, I mean, a cot, I mean, this one, it gives us what? Minus cosec squared. So if you integrate the reverse, it's going to be cot. So it was supposed to be pi over 6 cot of what? Pi x over the constant, the coefficient of x, which is pi. Always divide by the coefficient when you're dealing with integration. So this and this is going to cancel and gives us what? 1 over 6. So it's going to be 1 over 6, the cot of what? Of pi x. Just like that. We are done with everything. So after integrating, do not forget what? The constant of integration. So they will give you the mark to integrate each. So that's why I'm saying, guys, these are the basics, right? In the basic format where you can be able to integrate, because they can give you something that you cannot just integrate direct, just like even for the derivatives. So you must rewrite in a way that you can integrate. Then after that, you integrate each, and do not forget the constant of integration. The impedance of a circuit on question 5.2 is given by this equation. So that is V, the impedance of a circuit. Impedance, all right. They wanted to say the voltage. This is no longer impedance. The integral of this is V, isn't it? They're supposed to say Z. Anyways, let's just write, guys, the way that you're given. So that was pi over 2, not pi. I don't know what happened when I was just putting this one on the board, but it was pi over 2 there. All right. So, guys, this is just a normal integral that we are given there. The sine of x minus the cos of x with respect to x. Remember, these integrals are there in your formula sheet, guys, as it is sine, as it is giving us a negative cos. Cos as it is giving us what? The sine, but already there's a negative here. So it's going to be what? Negative sine of x. We are done, guys, integrating. Then you put your limits, pi over 2 and 0 sum. Can even convert to the degrees. If you want to convert to the degrees, guys, pi over 2 is what? 180 degrees over 2. So that's 90 degrees. So meaning to say, when you substitute your upper and lower, instead you can use minus cos 90 minus sine 90 degrees, or you can use the radians, but make sure that your calculator is in radians. The lower limit, that's a 0 there. So it's minus cos 0 minus the sine of what? The sine of 0. So the first part, if you simplify everything on the first part, it was going to give us a -1. All right, minus the second part, it was also going to give us a -1. But this is minus minus, so it's going to be a plus. And -1 plus 1, that's a 0. So at the end, it was going to give us a 0, this one. Okay? Yes, for calculation purposes, that is what you're having. You cannot argue with that. Say, so can that voltage be 0 or can that impede? No, it's a question that you're being mathematically, it was giving you a 0. So you just answer it that way. Okay. Moving on to 5.3, and that is 5.31. Sketch this. Okay. And enclosed by the graphs, the x-axis, all right? So it's enclosed by this graph and the x-axis, all right? That's a quadratic, a parabola. So remember, a parabola, first of all, it is the shape when our a is positive, as it is greater than 0, we are going to have it concave up. A is greater than 0, so that's the shape. Then we move on to the x-intercepts, where y is equal to 0. So that's x squared minus 2x minus 3 is equal to 0. You solve. You solve that. Okay, you can use a quadratic formula. You can use your factorization. It is up to you. So using factorization, since this is 1, I'm just going to have x and x here. I focus on the this constant -3. Its products or factors which you add up to -3. -3 and 1 mean which you multiply to get -3. That's -3 and 1, 3 and -1. But when you add, you must get -2. When you add, you must get -2. So this is the one. If you add this, you're going to get -2. So that's -3 plus 1. So we can solve for x. -3 to the other side is going to be positive. 1 to the other side is going to be what? A negative. So those are the intercepts, the x-intercepts. The y-intercept can be determined direct, because when x is equal to 0, y becomes what? The constant -3. So we have got our y-intercept. Thus, guys, when you are dealing with this sketch where you are to calculate area, those minimum turning points, they are not even important. Yes, we can find those minimum turning point, add these x values, divide by 2, or you can find it from minus b over 2a. You're going to calculate that and you're going to get 1. You substitute into the y value and get -4 as a turning point. It's not necessary when it is on this type where you are to do with integration. What is important, the intercepts with axis, those are the ones, and the shape. Remember, we said our shape is like this. A is greater than 0. So let's say this is -1. So that's 0, -1, 3. The y-intercept somewhere there, -3. So our graph was going to look like this to the y-intercept turning point, then it goes up like that. So the turning point is the one that I'm saying it's not necessary. Yes, you're going to indicate if you want 1 minus 4 if you want, but it was not important. So these are the ones that are important for this part. And where the area is enclosed by this graph and the x-axis, it is this portion enclosed, covered by the graph and what? The x-axis. So because the limits are there and they are for x, we can use the representative strip for what? For x. So that is our sketch. Okay? Just like that. 5.31. 5.32, using integration now, determine the value of that enclosed area, the one that you indicated, all right? The one that is covered by the what? The graph and the x-axis. So it is this region enclosed. So calculate the area, guys. So calculating the area, we can do it. Yes, using our integral. Remember, area is the integral of y with respect to x from a to b as our limits. y with respect to x. Y is a function of what? Is a function of x. So that is, okay. Did I write it here, guys? Do not forget to write it on your sketch. Okay, so that's our y. So we're gonna take our y as it is, integrate that. So that's it, guys. X squared minus 2x minus 3 with respect to what? To x. From where to where? Our limits, the x values from -1 up to 3. -1 being the minimum and 3 being the maximum value to the positive. So that's -1 to +3. So that was it. You integrate, you're done. So integrating, you add 1 on the exponent, remember. So that's x to the exponent of 3, divide by that exponent. We add 1 here, so it's 2x squared over 2. So it's going to cancel. So that's minus x squared. On a constant, when you're integrating, just put x there. So it's minus 3x. Our limits from what? -1 to +3. Substituting our limits, upper minus the lower. So in place of x, just put that 3 to the exponent of 3 over 3. 3 squared, all right, that's our x squared. So substitute that. It's going to be 3 squared. Okay, what happened? It's going to be 3 squared. I don't know, is it saving or what? Is it saving? Okay. Anyways, this is what? 3 squared minus 3 times 3 in place of x. So that's our upper limit minus the lower limit when our x is what? -1 to the exponent of 3 over 3 minus our x, which is -1 to the exponent of 2 minus 3 times our x, which is -1. So that was it. That was it. So the first part was going to give us -9. If we simplify properly, -9 minus the second part was going to give us +5 over 3. So now it's a negative because it's, remember, you're subtracting. So -9 minus this is going to be -32 over 3. So it is giving us a negative because of the region where it is situated. Here it is below the x-axis. So the value is a negative, but we need the magnitude of that area. So just write as a positive. So the magnitude is what? Positive. From the integral, yes, it's negative, but the magnitude of the area, you take it as a positive. So that's our area in square units. Or it can be 10,666 and so on and so on and so on. We have your area, the magnitude. So that's the condition. Below the x-axis, the area is negative. Above, it is positive on a calculation. But your answer, you put it what? As a positive. You need the magnitude of the area. So that is how these questions can be given as you can see, we've answered these two to sketch and also to determine the area from that sketch using what? Using our integration. So just integrate, then substitute the limits, upper limit minus what? The lower limit. Okay, then on 5.4, which is the last question of our April 2025 exam, we are given to simplify this integral. So there is, okay, let's just try to factorize first. 3x cubed minus 81. 3 is common. It is the highest common factor. So 3x cubed divided by 3. It was going to be x cubed minus 81 divided by 3, which is what? 27. So this is a difference of two cubes. 2 cubes. A cubed minus b cubed. Because 27 here is same as what? 3 cubed. So it is the same as x cubed minus 3 cubed. So how do we factorize this? It is a minus b into a squared plus ab plus b squared. So what you just need is to note what is your A and what is your B. This is our A and this is our B. So meaning to say automatically here it was going to be 3 into A minus B. So this is A, this is B. A minus B. X minus what? 3. Into A squared. Our A, which is what? X. So it's X squared. AB, that's X times 3. And X times 3 is same as what? 3X. So this is 3X plus B squared. Our B is 3. So 3 squared is 9. So this is what you were going to have. This is what you were going to have here. So it's the integral of 3 into this bracket, x minus 3 into this x squared plus 3x plus what? Plus 9. Everything over what? The denominator. And our denominator can also be factorized. As we can see, 2, this is 6, so 2 is common. We can factor out 2. 2x divided by 2, that's x. Minus 6 divided by 2, that's negative 3. So that is it. So we can integrate this with respect to x. Okay, these brackets can cancel. 3 over 2 is a constant, so you can even take it outside of the integral. Then you are left with this, which is x squared plus 3x plus 9. With respect to x, we can integrate each and every term that we are given there. So that was going to be 3 over 2. All right, let's integrate. Remember, integrating, adding 1. So that's x to the exponent of 3 over 3 plus, add 1. So that's 2, 3x squared over what? Over 2. 9 is a constant, so with respect to x will be given as what? 9x plus the constant of what? Integration. So this is it, you are done. You can even leave your answer like this. You can multiply throughout by the 3 over 2. So 3 over 2 times, this is 1 over 3. It was going to cancel. So it was going to give us 1 over 2 x cubed. 3 over 2 times 3 over 2, numerator to the numerator, that's 9. 2 times 2, that's 4. So it's going to be 4x squared. This is same as 9 over 1. So 3 times 9, that is what? 27. 2 times 1, that's 2x plus the constant of integration. In that case, we have integrated each and every part that we are given. But first, we had to simplify what we are given under the integral using our factorization. So it's not only about integration. It's not only you knowing the basics of your integration, it's also knowing all the basics of your mathematical skills. Factorization, where it is applicable, make sure that you do apply it. All right, where it is applicable, make sure you do apply it. So we shall see our next classes. Do not forget, guys, to join membership so that you do not miss any of the other classes. Those introductions that I was talking about, they are available on membership. So make sure that you do join the membership section so that you won't miss any of the classes that we shall have. Till we meet again.